Welcome back to Teaching the Unteachables, where we dive into teaching and learning methodologies for professionals like you. This episode brought to you by Stanfield Training Solutions, your source for HVACR training solutions. Learn more at HVACRfundamentals.com. Well, hello everyone. Thank you for joining Did You Know the ESCO HVAC podcast. So today we're joined by esteemed author Carter Stanfield. How are you, sir?
I'm doing great.
Author of Fundamentals of HVACR, published by Pearson. Carter is very involved with education as well as authoring in the industry. And we both have a passion for understanding where things come from. I always say that you can't know where you're going unless you know where you came from. And that's very true when we start talking about this A2L transition. And really, when we look at it, it's more about the low GWP transition because, yes, we're seeing the A2L transition, but we're also seeing an A3 transition as well. And so today we're going to spend some time talking about where the standards come from, particularly ASHRAE Standard 15 and Standard 34. And Mr. Stanfield has spent a lot of time breaking these down. And Carter, if you could help us understand a little bit about this transition and why we're doing the things that we're doing.
Sure. So I like to emphasize, you mentioned knowing where things come from. I like to look at the original documents to things.
Yes.
So while I love presentations given by people, I like to see the original documents where their information came from.
Absolutely.
So when it comes to refrigerant, ASHRAE 34 is the standard that really all codes and even the UL qualification refer to. So ASHRAE 34 is the document that gives the refrigerants, their numbers, and also it's where our safety standard comes from. So the A1 through B3 and all the numbers and A2L, all that comes from ASHRAE 34. So I like to be able to refer to the original document and see exactly how they define things. This is particularly important now as we try to understand what an A2L is versus, say, an A1.
Yeah, absolutely. A lot of people don't realize, where these transitions come from. We get a lot of calls at the ESCO office and sometimes complaints about these transitions going, why are the manufacturers of equipment doing this to us again? And it's actually never been the manufacturers of equipment. Like when we talk about this A2L transition, we're really talking about the HFC phase down that came through in two different ways. It came through with a Kigali Amendment to the Montreal Protocol, as well as a portion of the AIM Act. So not only do we have an act of Congress, but we have an international treaty that is phasing down the use of hydrofluorocarbon refrigerants. And so in doing that, we have to look at what are the next generations of refrigerants, how do we safely handle them, and what other refrigerants could we see going forward? Because this is just one step of a variety of transitions that I'm sure we're going to see. Now, many of us seen the CFC phase out. We've seen the HCFC phase out. We're now in the HFC phase down. And remember, it's not a complete phase out, but it is a phase down by 85% by 2036. So what that means is we have to start looking at what other refrigerants do we have to work with. And, we'll take chemists like Dr. Chuck over at Chemours, who says that the periodic table doesn't really grow. We just have to reuse the elements that we have. And in doing that, unfortunately, we end up with refrigerants that will have some mildly flammable and even highly flammable characteristics going forward. But then, how do you work with them? How do the manufacturers design the equipment? How do the tool manufacturers relook at and sometimes redesign their tools? There's a lot of safety that goes into that, and we have to have something to start with. And that's really where ASHRAE 34 comes into play.
Yeah, ASHRAE has been doing refrigerant safety for quite a while. And it is really the backbone of most of the refrigerant safety standards. ASHRAE 15, which is also widely documented, uh, is used in many codes. And essentially, all the rules for refrigerant mechanical rooms with refrigerant systems in them, basically refer back to ASHRAE 15. The issue that we've had with ASHRAE 15 is that it's primarily a commercial standard.
Right.
People don't have mechanical rooms in their houses. So ASHRAE 15.2 covers low-rise residential structures, and it specifically really lays out all the safety requirements for installing and servicing A2L systems. It does also cover A1 systems, but its primary purpose for being has to do with installation and service of A2L systems. And it was developed sort of in parallel with the UL, the number. Is that it?
6335-3-40.
Okay, thank you.
Yeah, absolutely.
And that UL standard actually came from an IEC standard of the same name, the same number. That's why they came up with that number, because they harmonized the standard with the IEC standard. There's something that, when we talk about worrying about global warming and getting rid of our high global warming refrigerants, this is not just a U.S. thing. This is an international thing.
That's right.
The reason it's important to manufacturers is that we don't want to be on an island. We don't want to be the only people in the world using a particular type of refrigerant or having particular kinds of systems. The manufacturers, both of the refrigerant and equipment, want to be international. They want their products to be able to sell their products someplace besides the United States.
Mm-hmm.
So that gives some impetus. It's not just the government. There's also financial and industrial things at play here. And again, it's an international movement. So it's not something that our government could just say, okay, well, we don't want to do this anymore because we don't believe in it. We'd be bucking the whole world, and basically it's sort of like isolationism.
When we start talking about the three different levels of mitigation, what we're really talking about is the refrigerant concentration levels based on the flammability of the refrigerant. And when we start breaking down those refrigerants, so we start in ASHRAE 34 to see what those flammable characteristics are, and then in 15.2, we can actually look at, well, when does that mitigation come into play? Because these smaller systems, under 4 pounds, and that's a rough estimate based on the refrigerant itself, under 4 pounds in these residential systems, they actually don't even have mitigation. But once we reach that potential for combustion, we start adding mitigation to it. And so what we're going to see in particular residential systems is mitigation controls, which is going to add a refrigerant leak detection sensor and a control to be able to mitigate those gases in the event of an actual significant leak.
Yeah. So on the mitigation levels, the UL standard and also the ASHRAE 15.2 refer to charge levels they call M1, M2, and M3.
Right.
I believe the M stands for mass.
That makes sense.
I haven't verified that with anybody. I'm just trying to come up with some reason why they use that.
Yes.
And then when they talk about the maximum charge and that sort of thing, they also use M. But anyway, M1 is 6 times the lower flammability limit. M2 is 52 times the lower flammability limit. And M3 is 260 times the lower flammability limit. So the weight amount varies with refrigerant because it depends on the refrigerant's density and the lower flammability limit of the refrigerant.
Right.
And it does. It's just under 4 pounds for R32. And honestly, I don't know right off the top of my head what it is for 454B.
I think it's
but
4.1.
It's
real
in
close.
In that same range. And to get perspective on this, I thought about PTAC units.
Yeah.
And I looked up a Friedrich PTAC unit of 12,000 BTUs, and their charge was 1.8 pounds of R32. So well under this 4 pounds,
Yep.
meaning that those units and say window units like you'd buy at your big box store don't require any kind of special mitigation. When you go between M1, the 6 times lower flammability limit, up to M2, 52 times the lower flammability limit, you do require mitigation. And there's lots of ifs, ands, and buts, lots of different things that alter what mitigation is required. So that gets kind of detailed. And then there's more mitigation required between M2 and M3. And at M3, the 262 times the lower flammability limit, basically that's outside of the UL standard. So that would require a whole different document.
Exactly. And that's going to be large quantities of refrigerant, large systems. Probably the only time we're going to see that is going to be in large VRV, VRF installations. And it really comes down to, once we get to that point, we're going to add additional controls like pump down solenoids and ways to be able to do additional isolation of the refrigerant itself.
Yeah. The mitigation varies a lot depending on the quantity of refrigerant and also where the system is applied. That's the other thing about Standard 15. The requirements for what you're allowed to do and what you're required to do vary based really on 3 things. The occupancy, that's the building, the refrigerant, and the system, the type of system.
Okay.
Yeah. So I'll start from here. The mitigation varies depending on the type of occupancy. That's the type of building it is, the type of system, the type of refrigeration system, and the refrigerant classification. So when we talk about occupancy, we're talking about, say, institutional would be hospitals and things where you have people that cannot easily move,
Be relocated.
that getting everybody out is going to be a chore.
Sure.
And then when you talk about systems, they've got several different kinds of systems, but it really comes down to whether something is a high probability or low probability system. Now, by high probability, they're talking about the possibility or probability of refrigerant getting in the airstream in the building if there's a leak. So, our typical direct expansion systems are all high probability systems because the refrigerant's in the coil that the air blows over.
Exactly. In the space.
Yeah. So, an example of a low probability system would be, say, like a chiller, where
Right.
refrigerant cools the water and then the water is pumped around. Even if you did have a leak, the chance of the refrigerant getting in the air is extremely
Minimal.
Yeah. So the standards are different for those. So until recently, the standard ASHRAE 15 would not allow flammable refrigerant in a high probability system. So the first allowance of any kind of flammable refrigerant in high probability system came about in the 2019 revision of the ASHRAE Standard 15. The ASHRAE Standard 34 recognized A2L refrigerants in 2016, but it was not until 2019 that they said in Standard 15 that you could use A2L systems in a high probability system. And there's, again, lots of parameters. So that's where we get into the mitigation, and the amount of mitigation and the type of mitigation varies based on the quantity of refrigerant and the application.
Yeah, a lot of people don't realize that like you'd mentioned before, a lot of our window units and PTAC units have already made the transition to A2L refrigerants. Pretty much any window air conditioner you buy right now has R32 in it. Same way
Oh,
with the PTACs.
yeah, you'd have a hard time actually finding a window unit that doesn't have 32 in it.
Exactly. And because of that charge limit of around 4 pounds, most of those window units have a pound or under of refrigerant, so they have no additional requirements for mitigation. In our residential and light commercial applications, we're going to see factory leak refrigerant detection sensors as well as the controls that go with them. If it is a non-communicating system, it's going to have an independent control module, which is basically going to be connected between the thermostat and the indoor unit, so that in the case of a detection, we're actually going to go into a mitigation state, which is going to turn off the outdoor unit. It would turn off any heat source inside, whether it was electric furnace or whether it was a gas furnace. It would actually turn off those ignition sources and turn on the blower to dissipate those gases. If it's a communicating system, most of our manufacturers have incorporated that control into the indoor board. And so literally it's a matter of just connecting the sensor that comes with the coil down to the control board of the indoor unit, and now it's actually ready for a mitigation capable system.
Yeah, I didn't know that. That's good information.
Yeah, I've spent a lot of time on how we're actually utilizing the mitigation controls. So if it is a non-communicating system, you're going to have an additional control board. If it is a communicating system, the same refrigerant detection sensor is just going to be plugged into the primary control board of that indoor unit. At least that's what I've seen with the manufacturers that I've went through so far. And then when we get into our VRV, VRF, because it's already a communicating board on the indoor unit that is able to communicate to the outdoor, we're just adding the additional refrigerant detection sensor and it plugs directly into the control board. So as our systems make the transition, it's going to be a little bit of a learning curve, understanding what that installation looks like. And in the installation manuals that I've seen for our residential, like commercial split systems, they actually give you all of the dimensions for if this system is installed in this cubic amount of space, mitigation is required, and here's how you make the connections. So it's pretty basic, but it is definitely a transition that we're going to be making, and it takes a little education. And so the whole conversation today was, where does that education come from? Most of it comes from Standard 15 and Standard 34.
It's interesting that you mentioned the room volume. It is one of the kind of significant changes. Uh, the manufacturers, part of the UL standard is they have to, with the equipment, when it's checked for the UL requirement, they have to actually supply the installation instructions that they're going to package with the equipment. And they have to provide uh, tables rather than just formulas for the
Correct.
technicians to be able to determine whether or not a particular piece of equipment will safely work in a space. And they do that two ways. One is they tell you equipment with this charge can go in a space no smaller than, and they give you, the volume. And the other is they say, well, if your space is this size, the maximum charge you can have is, and they give you a number. You're also going to be required to calculate total charge, meaning in a split system or a mini split system, adding charge for the line set. Now, of course, that's not that new, but now it's a
There's
really
a
a
limit.
legal requirement, and something that a lot of speakers have mentioned in their A2L presentations is a lot of behaviors and procedures that have been best practice are now required practice if you want to do it safely.
Exactly. So that's all. It's a little bit of education. doing best practices are going to get you through a lot of the hurdles. Otherwise, your installation manuals and training from your manufacturers and industry partners, like all of us, are here to help educate you and keep you current. So, Carter, if you're looking for more information, where are some ways that people can locate Fundamentals of HVACR and Carter Stanfield?
So I have a blog, HVACR fundamentals.blogspot.com, and I have a website, HVACRfundamentals.com. And then if you can also Google Stanfield Training Solutions, and I believe my website will come up. Also, you can go to Pearson. Pearson has a website for the book, so you can Google the book title, Fundamentals of HVACR, and you should be able to find that Pearson website.
Fantastic. Mr. Stanfield, we sure appreciate you joining us today.
Thank you very much.